This is part two to question one for April 28th, Tuesday, grade 4 math. So there's a big X on this page. It says study Rafaela's incorrect work. It says solve 5 and 2/10 minus 4 and 3/10 equals 1 and 1/10. It seems like she started by decomposing and subtracting her whole numbers. So 5 minus 4 equals 1. And then she subtracted 3/10 minus 2/10 equals 1/10. And her final answer was 1 and 1/10, which was incorrect. So the first question says, why can't Rafaela subtract 2/10 from 3/10? So before we answer that, let's solve this problem ourselves because it's important that we know how to solve because we can't really analyze work without solving. So 5 and 2/10. So I'm going to grab 5 wholes because I know that my mixed number is 5. So 1, 2, 3, 4, 5. And I'm going to put these here. 1, 2, 3, 4, and then 5. So we have 5 wholes and 2/10. So I'm going to grab one more of these and I'm going to shade in 2 out of 10. So we have 1, 2, 3, 4, 5, and our 2/10. Okay. And we are subtracting 4 and 3/10. So the question says, why can't Rafaela subtract 2/10 from 3/10? So if you look here, you can see our 2/10 shaded in. If we only work with this rectangle, are we able to subtract 3 yellow parts? If you said no, you are correct because there's only 2 parts shaded. So that tells me that 2 out of 10 parts are shaded. So think about your knowledge of subtraction. What do we do when we need to subtract more than is allowed? If you said unbundle, you are correct. So we're going to take away these 2 parts, and then we're going to have to move to one of our wholes and take away 1 part to subtract those 3/10 because we just took away this 10th, this 10th, and this 10th, which means that's 3/10. So now let's move. We subtracted 3/10. We also have to subtract 4 wholes. So let's go back to our fraction model. Do we have 4 wholes here? If you said yes, you are correct. This is 1 whole, 2 wholes, 3 wholes. So really, I'm just gonna cross these out because these aren't really here. We subtracted. And now look at the image. What do we have left? How many wholes do we have left? If you said 1, you are correct. This is 1 whole. And let's see how many tenths we have left because I can see there's a missing piece here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths left. So we have 1 and 9 tenths left over. So that should be our final answer, which we already know there's an X on her paper. Rafaela got a different answer, but let's go back and look because this is a really unique concept in subtraction. We need to unbundle and regroup when we're subtracting 3/10 because as noted on the paper, we only have 2 rectangles here, so we have to move to another whole and break from there. This is an important thing. It's like regrouping when we subtract and unbundling from our 10s if our 1s. Some people say borrowing, but it's another strategy we can use. So that is why she cannot subtract that number. Okay, sorry if you heard the oven in the background. It says finish decomposing 5 and 2/10 by filling in the box. So let's go back to our fraction model. We have 5 and 2/10 here. And the student broke it into 4. So we have 5 and 2/10. We have 4, which is 1, 2, 3, 4. And how much goes in our other part of our number bond? 4 is represented by 1 whole, 2 wholes, 3 wholes, 4 wholes. So that's really this, 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 and this. And how much is left over? Oh, we want to keep that there. So there's 2 tenths left over, which we see here, but there's also 1 whole left over. So we can represent that by saying 4 plus 1 and 2 tenths equals 5 and 2 tenths. Because 4 plus 1 equals 5 and 2 tenths is represented here. So you can note that here. You can also represent that by an improper fraction, which is kind of what the question is asking us to do. So I'm going to erase this because it's asking us, I didn't see that before, that our denominator is 10. So it did not ask for a mixed number. So let's count our tenths. We know we have 10 here. And if we add 2, that makes 12. So we have 12 tenths. So 12 tenths plus 4 is also equal to 5 and 2 tenths. You can also represent it the following way that we did. The last question says, how would decomposing 5 and 2 tenths in this way make it easier for Rafaela to solve the problem? So I'm going to let you solve that by yourself and explain why would we decompose that way. Think of fraction models and think of the mistake Rafaela made.